So before we start today, I would like to introduce a couple of fun applications. They are web apps developed by the University of Colorado Boulder, and they cover several topics related to physics as well as other areas of science, chemistry, maths, earth sciences and biology. So I will share the link of this web app collection actually as a Canvas announcement. But to just have a quick idea, you can see here that if you just apply a filter to physics only, you will get a collection of 56 web apps, interactive apps, which are very fun to play with. So I sorted out around 3 or 4 which are very relevant to the topics which we are discussing in this course. For example, let's look at the projectile motion kinematics app. It is in the whole list of physics related apps. You can search or check each one of them. So for example, if you go to that projectile motion kinematics app, it not only provides you with the relevant teaching resources, some activities which you can do with this app and some other information. You can just play any of them. For example, this projectile motion would give you 3 or 4 modules. If you simply go to introduction in that, you will be seeing a interactive application in which you can provide any input variable related to projectile motion, and the app actually provides you the whole path of projectile, and then you can play with these things, vary different inputs and see how the path varies and all that. It has 2 options. One is including air resistance in the calculations and other is not including, so you can check or uncheck this. If you want to include air resistance, then you have to give a coefficient called drag coefficient. It will govern how much resistance the particular object which is undergoing a projectile motion will experience while it moves through the air. If you look at the automation which is implemented in this app without air resistance, it would be simply those 5 equations of kinematics which we have studied already. So those 5 equations are enough for you to determine the path, the complete parabolic path of a projectile. But those 5 equations will work only for the cases when you don't want to include the air resistance in your calculations. So for example, it has this cannon symbol which you can rotate by simply mouse. So you can change the angle of projectile, then you can change the initial speed using a slider at the bottom. This is in SI units, right? And you can also increase or decrease the initial height of the projectile, right? Similarly, you can also have a target range on the x-axis, so you can move it with your mouse, right? It provides you with a couple of tools also to calculate, for example, distance between any 2 points. So there is a measuring tape symbol here which you can just use and drag with your mouse anywhere, right? And then you can put it back in that toolbar also. On the right hand side, you can see there are different options. It gives you like what thing need to be thrown in projectile motion. So for example, cannonball would have a different weight, baseball, human, or even a car also, right? Each of them will have a different weight. But now you know already that the weight of that object will matter only when you include air resistance in your calculation, right? In this course, we haven't covered the mathematical formulation to include air resistance in our calculation. So the weight of that object will become irrelevant, at least for this discussion now. But later when you will see that formulation in which the drag force is also included in our equations, now you will see that the weight of that object also need to be required to actually calculate the path while including the air resistance, right? So currently if you uncheck air resistance, that weight of that particular object mass and diameter won't affect the calculation or path, right? So for example, let's start with cannonball, and you can also visualize the velocity vector and acceleration vector and its both components by checking these options, and the symbol will show you all along the path. For example, let's start with an initial velocity of 15 meter per second and an initial launch angle of 40 degrees. So this is the symbol actually to just launch the projectile. So I just start that. So it actually calculates the trajectory at different time instants and plot it using a blue line, right? So you can first of all check whether you have achieved a particular target range or not. But most importantly, you can play with input variables to kind of internalize and get an intuitive sense of how the different variables would affect the path. For example, currently we haven't included air resistance in our calculation, so we are actually following the ideal projectile motion. So actually it shouldn't matter whether we selected a cannonball or a piano or a car with 2000 kg mass, right? So even if I repeat the same, launch the same projectile using a car, it will exactly follow the same trajectory because there is no effect of air resistance. But let's include it. For example, in this case, let's start with football. So again, it doesn't matter because we haven't included air resistance, but if we check that and then we repeat that launch option, you will see that now it has a different trajectory, right? So including air resistance have kind of reduced your range. So now it is hitting at some other point. Similarly, you can play with the effect of initial speed here, repeat the same exercise with different initial speeds. You will see that trajectory is different. High initial speed will give you higher range, right? So now you can see that it simply goes out of the canvas which you are seeing here. You can also play with the initial height, right? And it will plot the trajectory every time. You can play with the speed of that projectile also. And finally, you can also visualize the total velocity vector and total acceleration vector along the path also. For example, let me repeat with some reduced initial speed. So you can see that at any time instant, the acceleration vector, which is a yellow arrow, it remains vertically downward, and then you can see the velocity vector is always tangent to the path, right? Velocity vector is shown by the green arrow. Similarly, you can also visualize its components, velocity and acceleration components. If for example we talk about velocity component, one thing you can notice that the x component of velocity remained constant throughout the path, right? And we know it from the 5 equations also that v sub x remains same as v sub naught x, right? So the velocity throughout the projectile in x direction remains same as the x component of the initial velocity. But y component varied throughout the path. It became exactly 0 at the apex, right? So v sub y should be equal to 0 at the apex, but then as the projectile continued, it had different values. Similarly, if for example your range target is 30.8, we can see whether it achieved that target or not. So it shows using some animations that you have achieved the target of range which you initially intended for. Similarly, you can play with other modules of this application. Similarly, there are other applications like vector addition. It is an interactive app which allows you to draw the vectors, and then you can take their summation and then visualize the directions of vectors. So you can play on this canvas by changing different things, adding vectors, subtracting. So you can do vector operations here. Similarly, this app is Calculus Grapher. It helps you to visualize the integration and differentiation of a particular function, right? So if you go to derivative function, then you can have an f of x on top, and in real time it will plot you the f prime of x or the first derivative of x, right? So You can have different types of functions on top to see how their differentiation graphically would look like, right? So please do spend some time in playing with these apps. You can find some other also in that whole list which may be relevant to our case. As we move along kinetics part of this course, you will see that some of them, for example, the apps related to the visualization of forces will be really helpful in increasing your visualization sense in terms of forces and their effects, right?